You are welcome to SK Pass International College. I will entreat you to share this video. Please subscribe to this channel so that anytime there's a new video, you can get access to it. And then like the video. Most of you have been watching the video without liking it. So please like the video and share. We are still on chemical bonding. We started with the first video and the second video on this chemical bonding. So if you have not watched the first and the second video, kindly watch so that you can understand this concept well. And if you also want to contact me for any tutorial service, you can contact me on 059 or 020-74-322-71. Alright, today we are going to look at another interesting aspect of the Lewis dot structure. We are on ionic bond, but under this ionic bond, we said that we are going to learn how to draw the Lewis dot structure using a very nice trick, so that anytime any molecule is given to you and you are asked to draw its Lewis dot structure, you can easily do that. So let's start. Assuming you are asked to write Let's assume you are asked to write the Lewis dot structures of the following. The first one is hydrogen cyanide, triazocarbonate 4 ion, tetraozosulfate 6 ion, and ammonium ion. You need to get some basic concepts so that you can easily write the Lewis dot structures of this. You can see some of them are radicals. So let's begin with the first example. We are going to come out with some rules. Try to memorize those rules. It may look lengthy, but if you continue to practice it, we said chemistry itself is try. If you keep trying, you will have mastery over it. So let's start. If I want to write the Lewis dot structure of any molecule, the first thing I will have to do is to, so rule number 1, calculate So we are going to calculate the total number of valence electrons. So I'll not write again, but I'm going to denote that by N1. So I'm going to represent, in this presentation, I'll represent the various concepts with N1, N2, N3, and N4. So our N1 is to calculate the total number of valence electrons. So let's pick the first molecule, which is hydrogen cyanide. If I want to calculate the total number of valence electrons, we are only looking at the valence electrons. Already we have said that we use the valence electrons in chemical bonding. That's why we are using the valence electrons. So what is the valence electron of hydrogen? That is 1. Carbon belongs to group 14, so its valence electron will be 4. Nitrogen belongs to group 15, so its valence electron will be 5. Quickly, this will give me 10. 1 plus 4 plus 5 is 10. So this, we have 10 valence electrons in hydrogen cyanide. The rule number 2 states that we are going to use a formula to get N2. So we are done with the N1. So this is my N1 value. N1 is equal to 10. With my N2, we are using the formula 2 times number of hydrogen atoms plus 8 multiplied by number of other atoms. So that is the rule. 2 multiplied by the number of hydrogen atoms plus 8 times the number of other atoms. Here we are dealing with atoms and not elements. Take note, there's difference between atom and element. Alright, so we have 2 number of hydrogen atoms here, we have only 1. Plus 8 multiplied by other atoms. So we have carbon having atomicity of 1, nitrogen 1, so 2. So quickly, we are going to get 2 plus 8 times 2 is 16, which is giving us 16 plus 2 is 18. So that is our N2. N2 is 18. Now, in getting the N3, all that you need to do, N3 is equal to N2 minus N1. And that is giving me 18 minus 10. And this is giving me 8. So that is my N3. Now, what is the essence of getting the N3? The essence of getting the N3 is to know the number of bonds in that molecule. So, for you to know the number of bonds, is N3 divided by 2. So, the value of N3 is 8 divided by what? 2. And that gives us 4. So it means that we have 4 bonds in this hydrogen cyanide. 4 bonds. Now let's look at, we get another N4. We need to also look at N4. How do we calculate for N4? N4 can also be calculated by saying N1 minus N3. N1 minus N3. So what is N1 value? We have N1 to be 10 minus what is N3 value? We have 8. So when you do that, you are going to get 2. Now your ability to get the N4 will enable you to get what you call lone pair. Now what do you mean by lone pair? A lone pair is a non-bonding electron. Any electron that do not undergo bonding is called a lone pair. So you need to also know the bonding or the number of electrons that do not undergo bonding. So that is why we calculated for N4. So N4, let's look at number of lone pairs is N4 divided by 2. So I'm going to get 2 divided by 2, which gives me 1. So it means that in hydrogen cyanide, there is 1 lone pair. There is 1 lone pair. Now, getting all this, getting your N1, N2, N3, N4 value correctly will enable you to draw the lowest dot structure for any molecule. Not just hydrogen cyanide, any molecule. But there are some exceptions which I will get there very soon. So with this concept, after getting all this, you will now look for the most electropositive element. This is hydrogen cyanide. So with this hydrogen cyanide, if you look at the most electropositive element here, that is the central atom, that is carbon. Carbon becomes the central atom. So you bring the central atom here. There are 2 other elements. So you ask yourself, how many bonds were formed? Per the calculation, we had 4 bonds. That is the N3 divided by 2. We give us the 4 bonds. So we know we have other 2 elements, but let's bring 1 element here, hydrogen. Then the next one here as nitrogen. So we have used 2 of the bonds. We have used this one and that one. We are left with 2 extra bonds. But in this case, you need to be considerate. This hydrogen, its atomic number is 1. And you know, hydrogen, as you see now, is already stable. Okay, it needs only 2 instead of 8. So if you bring these 2 here, already the hydrogen is fully filled, so it does not need extra bonds. So it means that the 2 extra bonds will be deposited here. Take note of that. You cannot bring the 2 other bonds here. It will violate the state or the stability rule according to the lowest dot structure. You should have a fully stable central atom, and that central atom should have 4 covalent bonds or 4 bonds around it. So from here we can see that This carbon is now having 1, 2, 3, 4. So it is fully filled. And we have exhausted all the number of bonds. But remember, we had one lone pair. The question is, where do we place this lone pair? We cannot place the lone pair on hydrogen because hydrogen is already full. We cannot place the lone pair on carbon. Carbon is also full because it has 3 plus 1, 4 bonds. But if you look at this nitrogen, 1, 2, 3, nitrogen is not full, so it needs another pair, which we call the lone pair. These do not partake in the bonding, so they are called lone pairs. So this lone pair will be on nitrogen. This is the Lewis dot structure of hydrogen cyanide. It may look lengthy, but if you take your time, within the shortest time, you'll be able to get the N1, N2, N3, and N4. Note, for you to get the number of bonds, you divide the N3 divided by 2 will give you the number of bonds. For you to get the number of lone pairs, the N4 divided by 2 will also give you the number of lone pairs. With this concept, you can pick any example on your own, any molecule on your own, follow the rules, and draw its Lewis dot structure. Write your answer in the comment section, whether you were able to do it or not. If you're able to do it, tell me yes. If you are not able to do that correctly, just write no. Contact me personally for us to discuss. Thank you for watching this video. We are going to look at another example in this video. But do you know something? This time around, I'm not going to quote all this because we know the rules already. So we are just going to apply the rule quickly. Let me do the second one, then you do the third and fourth one and post your answer in the comment section, yes or no. Provided you are able to do it, say yes. If you are not able to do it, say no. Alright. So this is a radical. In this case, anytime there's a radical like this, 2 minus, so we are going to add 2 extra electrons at the valence electron. We are not going to add. We only add when it is positively charged, like ammonium ion. I've given that an example. So this one, carbon has how many? We have carbon is 6, so 2 is to 4, so it's 4, plus oxygen is atomic number 8, which is 2 is to what? 6. So oxygen is going to be 6 multiplied by 3 plus 2. The reason why we are adding this plus 2 is because of the valency or the charge of this radical. So this is 4 plus 6, 3 is 18 plus 2. So this is giving us 24. And this becomes our N1. Getting N2, we said we are using the formula. This time around 2 into bracket number of hydrogen atoms. There is no hydrogen for this. So we are just going to use 8 times other atoms. The other atoms here we are talking of atoms and not elements. So we have 1, then this is 3. 3 plus 1 will give us 4. 8 times 4 is giving us 32. So this is 32 as our N2. We said that getting N3 is equal to N2 minus, so it's 32 minus 24. So N3 is giving us, this time around is giving us 8. So number of bonds is equal to 8 divided by 2, and that is 4 bonds. So we have finished with this. N4 will give us N1 minus what? N3. And this is the N1 we had what? We had N1 to be, let me look at N1 10, then N3, we had N3 to be 8. So this is 10 minus 8, and that is giving us what? Now let me look at minus N3 for this particular example, we had 8. Okay, so 8 minus 24 minus 8 is giving us what? 16. 16, right? Said number of lone pairs is equal to N4 divided by 2. So 16 divided by 2 will give us what? 8. 8 lone pairs. 8 lone pairs is giving us something like this. Let me draw this so that in our next video we continue. So let's look at the central atom, carbon. This is one oxygen. One oxygen is here. Okay, let me draw it.